Hi all, welcome to SK Data Diaries. Myself Sendil Kumar, I'm working with the MNC as a data engineer. In our earlier video, we talked about RDD, which is fundamental block of our Spark engine. RDD is known as lower level API. So what is higher level API and what are the options we are having as higher level API? When I say higher level API, we work with the schema. RDD doesn't come up with any schema. Main difference between lower level API and higher level API is schema. In higher level API, we work with the schema. By working with the schema, we can make the process easy for Spark engine. So schema is the main difference between our lower level API and higher level API. So what schema means? Let us see. For that, I'm going back to our database. Here you can see each row represent transaction. For example, you take first row, it is saying Airbnb laid off 30 people and raised the fund of 6,400 million. It happened in US on the date of 2023. Okay, but what this header saying? This header is giving the idea about the data which we are having. For example, you take this column, this header is saying this column having the detail of the company, which means the header column giving us the data about the data, which is known as metadata, alias schema. So, schema is nothing but the data about the data. That is the main difference between our RDD and then higher level APIs. So what are the higher level API we are having? We are having DataFrame, Spark SQL and Datasets. Understand this concept better, let us go back to our RDD demo. Here you can see while defining RDD, I didn't give anything about schema. It purely handle the data according to our transformation logic. So when you work with a lower level API, you have to write more number of code to do the basic transformation itself. That is why we need higher level API, which make our job better and make Spark more performant. You can see here for taking word count, we wrote flat map transformation, map transformation, reduce by key transformation. With the higher level API, we can simply done this transformation with group and count keywords. Let's see how to define the schema when work with the higher level API. Spark keyword is the entry to our Spark engine. Then dot read, which means we are informing the Spark to read the file. Here you can see I mentioned .csv. This is the place we have to mention our file format. Inside that parenthesis, we have to give the file location where the file is residing. This dot option is the optional keyword where we can give the additional information to Spark. Since my file have the header, I provide dot option header equal to true. Same way, I mentioned dot option infer schema is equal to true. This infer schema keyword go to my file and try to infer the schema from the file. In my file, I'm having SPID, GeoID and PID stored as a string. Sales date as a timestamp, amount, customers, boxes as a integer. If you see here, it inferred the schema from the file and provided exactly the same value what is there in the file. But you have to keep in mind that infer schema is not the production friendly way. If you read the file which is in the size of TBIS, this infer schema keyword put lot of pressure on our Spark engine. It is always advisable to define our own schema. This dot print schema keyword show us the schema of our data frame. Now we understood how to define the data frame and print the schema of our data frame. Dot display keyword help us to visualize the data frame which we are having. Here you can visually see the data frame which we are having. As I mentioned earlier, we have to provide our file name here. You can see .json instead of .csv. Likewise, we have to provide our file name and its file path. Parquet is one of the columnar format which widely used in data engineering. We talk about columnar format in upcoming session. Let's see how to apply basic transformation on data frame. You imagine I want to filter the data where amount is greater than 10,000. Here you can see on sales data frame, I am using dot filter keyword and provided column name and condition. If I run this transformation, it will give me only the data where amount is greater than 10,000. Here you can see the data frame is get filter. You have to keep in mind that for capturing the transformation, you have to assign this to another data frame. For example, I assign this transformation to another data frame. In this way, our transformation get captured. As of now, we talked about data frame and basic transformation we can apply on data frame. Let us see how to do the same with Spark SQL. You can use SQL kind of syntax inside Spark SQL. People who know good understanding in SQL, you know what is temp view. Temp view is nothing but the temporary view where we hold our intermediate data and we use this for ad hoc analysis. But temp view is not persistent. For creating a temp view on top of our data frame, we have to write dot create temp view and inside the parenthesis provide the table name which we want. Here I created a temp view called sales table. For using SQL like syntax, we have to use .sql keyword. Here you can see after Spark, I used .sql. Inside parenthesis, I used SQL like syntax. Select star from table name. Again, dot display will visualize the data frame. Here you can see the data frame exactly looks like our Spark DF. Let me apply the transformation which I applied on our Spark data frame. Applying a transformation on temp view is exactly like our SQL. Here I added where amount is greater than 10,000. In this way, I am filtering the data where amount is greater than 10,000. If we compare our result with our previous transformation which we did on our Spark data frame, it's exactly the same. Spark creators itself, they mention there is no performance difference while using a Spark SQL and data frame. As I mentioned, TempView is only session scope. Then how we can create a persistent table like a SQL table? Here we can create two type of table. One is external table, another one is managed table. In case of external table, our data gets stored somewhere. Our schema gets stored in our Hive metastore. When we drop our table, our data is safe in the storage layer. Only our metadata get dropped. But when it comes to a managed table, if we drop our table, both the data and metadata get dropped. For doing this demo, I am creating a database called SalesDB. After creating a DB, I am listing all the DB available. Here you can see there is two DB available. One is default, another one is SalesDB. If you didn't mention the DB name, it will get stored under default. All these DBs which we are creating here, it gets stored under Hive Metastore. Now let me describe the DB which I created. You can see here the DB is created under the location called hive underscore warehouse, which means our DB lying inside the hive metastore. For creating a table, we have to mention DB name and table name, and we have to provide schema. Now our table is got created, but there is no data inside our table. Now I'm inserting data from our temp view called sales table. If you see now, data is inserted into our sales table. In this way, we can insert the data into a table by using temp view. But this table is managed table. Data and metadata get dropped if we drop our table or database. To create an external table, while creating a table, we have to provide a location of the file where the exact file is residing. In that case, data will be safe in the path, only metadata get dropped. With that note, I'm ending today's video. I hope I added some value. Don't forget to subscribe the channel and press the bell icon. Keep learning, happy learning.